morning, Nandal. Myself, Jagadish, Assistant Professor, Department of CSC, DITM, Bellary. Today, I am going to tell about the CGV Labs third program. It is program to draw a color cube and spin it using OpenGL transformation matrices. In this, I am going to discuss about what is this color cube and how the spinning takes place through OpenGL transformation matrices. Yeah. So in this, I will explain what are the sequence of steps to be followed to create a color cube and spin it using OpenGL transformation matrices. Here you can observe, here we can find the cube here. How many faces are there? Totally six faces are there in the cube. And totally how many vertices are there? One, two, three, four, five, six, seven, eight. Eight vertices are there, and each has its own coordinate values, x, y, z values. To draw individual vertices, they require x, y, z coordinates that is being initialized in the uh, array variable called vertices. We'll discuss this one. And then, as I told already, we require 8 vertices to draw this particular cube, and how this particular color cube is made means by using the six polygons, this particular color cube is made. You can observe here 0, 1, 6, 7 vertices means the one polygon, whereas 0, 7, 4, 3 means the one more polygon, whereas the 4, 3, 2, 5 will make the one more polygon. Next 6, 5, 2, 1 makes the one more polygon, whereas the 7, 3, 2, 6 will make the one more polygon. In this way, to create a color cube, some six polygons are utilized to form a color cube. We will discuss one by one. So this is an idea as how the color cube look like, and here this is the cube, and this cube is having totally uh, 8 vertices and six faces. We'll see that. We will come from the um, main function. And before going to that one, we can observe here now we have created the cube, and we need to spin this particular cube by using the transformations. That is what the task here. We need to create a color cube and spin it by using the OpenGL transformation matrices. We will see that one by one. Um, and here, first we will start with the main function. We know this, okay, black image initialization, black image display mode, you know this double buffer, coloring we require, and depth buffer for 3D diagrams and all we require the depth buffering. So this is what the initialization is done for the display mode, whereas the black image window size, this is 500 by 500 size is taken, um, and there is a create window. So for the output window, we require a title. The title is rotating a color cube. Whereas glad reshape function. So what this glad reshape function will do means it registers the callback handler for window resize event. You'll see this my reshape. We'll go to the my reshape. Already you know this. What is this report? What is the matrix mode, GL projection, load identity matrix, whereas how current matrix is multiplied with the orthogonal matrix that is being shown in the myReshape function that is being done. Next, let display function, actual object what we want to display, that will be done in the function called display. So now we will move to the display function. We can observe here there is a display function. GL load identity. It is loading the load identity matrix, and GL rotate F, rotate float. Here you can observe theta of 0. This particular theta um, array is initialized with 0, 0, 0. Three values, three elements with this particular array containing. So this is initialized with 0, 0, 0. And once the display is called, you can observe here load identity matrix, rotate F, and rotate the theta of 1. Initially, this theta of 0 is 1, theta of 1 is 1, theta of 2 is also 1 initially. And here, this particular function makes the rotation via the x-axis, second one will make the rotation via the y-axis, and third one will make the rotation via the z-axis. How we are seeing here based on the x-axis, y-axis, z-axis. This is x-axis, this is y-axis, and this is z-axis. So to rotate them in three axes, x, y, z axes, these three functions are called. Okay. And color cube. First, we need to create the what is the objective here? We need to create the color cube first. Then we need to spin a color cube. First, we will see how the color cube is created. For that, we are calling the function color cube. Just we need to jump to the color cube here. Here is the color cube. You can observe polygon 0, 3, 2, 1. How we are mapping this one? Here 0, 3, 2, 1. This is one polygon. This polygon is made by making use of the four vertices. So those indexes are given here. 0, 3, 2, 1 is the four vertices. This particular thing will make the polygon. Whenever this particular polygon function is called, it jumps to the polygon function. You can observe here. A will receive the 0, and B will receive the 2, the sorry 3, and C will receive the 2, and D will receive the 1. So like this, GL, this is the built-in function to create the polygon. You can observe here, color also we have given, color A. What is this color A? A is what? 3, 0. It goes here. You can observe colors of 0, 0. Where is the 0? And this is a 0, 0, 0, 0. So it is this particular color is taken, and you can observe GL vertex PFV. This is the vertex PFV. How the vertex is made? To make a vertex, we require the three coordinates x, y, z coordinates. Where is the value of this is a vector? Vector means it requires more than one value. Means in this case, it requires the three coordinate values. Where is the three coordinate value? It is available in the vertices array. Vertices of A. A is nothing but 0. So the vertices of 0. What is there in vertices of 0? Minus 1.0, minus 1.0, minus 1.0 will be taken, and it creates the vertex. Whereas the second one B, what is this B is containing? 3 is containing what is this of 3? Where is that? 0, 1, 2, 3. So here is the thing minus 1.0, 1.0 and minus 1.0, and once again it draws the um, vertices. What is the, where is the vertices? This is the vertices to draw this particular function vertex 3 of is called. Next is 3. Sorry, vertices of C. What is the vertices of the 2? So it goes to vertices of 2. Here it goes and it takes the value 1.0, 1.0 and minus 1.0. By taking them, it draws the vertex. And of B. B is nothing but 1. So it goes here 1.0, minus 1.0, minus 1.0. 3 coordinate values are taken and it draws the coordinate. And finally, it combines them. All four coordinates are combined. It appears like this particular polygon. This particular polygon, it appears like. So this makes the one face of the color cube. In the same way, it calls the polygon function first time, second time. So at this time, polygon of 2, 3, 7, 6. this particular function is called a will hold the value 2 and b will hold the value 3 and c will hold the value 7 and d will have hold the value 6. So by taking them, um, start creating the vertices and to make the polygon. You can observe what is f of a. A is nothing but 2. What is f of 2 is 1.0, 1.0 minus 1.0. This is the thing. Whereas next one is 3. Here is the 3. What is f of 3? 3 is here. This one minus 1.0, 1.0 minus 1.0. This is a 3 and 7. Where is the 7? This is a 7 and this is a 6. So it makes this particular polygon. Okay, like this. It makes the 6 polygon to make a color cube. So like this polygon will be called for 6 times and in turn this polygon will call the GL begin color free of vertex 3 for 4 times and so on. In this way, it creates the color cube and you can observe for each vertices it takes the different color here. You can observe whenever the A value changes automatically different colors will be taken. Here we have the colors array here 0, 0.0, 0, 0.0, 0.0, next 1.0. So you can observe here in the color cube individual vertices having its own color. So this will be formed by this particular color tree of the mesh. Okay. So uh, this completes the color cube creation. This completes the color cube creation. Then um, blood swab buffers. Blood swab buffers. What is its job? Blood swab buffer is a blood function that instructs the computer that you are done with the current frame and the buffer should be swapped so that uh, frame be displayed and so that you can begin working on the next. Here, current frame will be there, next frame will be there. So current frames displaying is over. Next frame should be displayed. For that, this particular function will work in stopping the things. After display is done from the main function, it goes to the let idle function. The meaning of this one is let idle function. Whenever no animation to display, whenever some event is not occurring, automatically it spins the color cube. So this is with respect to the interactive function. Here one thing we need to discuss here, there is a function called mouse here. This particular program depends on the mouse event. Whenever you click on the left mouse button, it rotates the color cube in x-axis. Whereas whenever you click on the scroll the middle button, um, it more rotates the color cube in y-axis. Whereas whenever you click the right button, it rotates the color cube in z-axis. This is the interactive mouse event being included in this particular program. You can observe here based on this idea. Whenever we call glut idle function, whenever um, any mouse event is not occurring or user has not clicked not calling any of the event like a keyboard event or mouse event. So usually what happens, it spins the cube. It spins the cube. What is the spin cube? So already we have created the cube and it should be always spinning in its own axis. So you can observe spin cube is the function. It spins the color cube in its own axis. You can observe theta of axis plus equals to 1.0. You can observe theta already theta is an array. It contains initially 0.0 and in the same way this particular theta is changed for every loop plus theta of axis plus or equal to 1.0, every time this particular color cube is pinned with one angle change. So like that, your theta of axis will move till the 360. When it reaches to the 360, automatically your uh, uh, axis will go on reducing. So like it reduces it will move till the 360 degree. Once it reaches to 360 degree, automatically it goes to the 0 degree. Once again it start displaying, and here you can display glut post redisplay. The meaning of this one is usually um, whenever we not use this particular function, um, it moves to the main function's next function call. But here, what is the task here? The task is it should spin the created color cube without any stopping. For that, we need to call a function called let post redisplay. What it does means just we need to post the redisplaying of the main function, and we need to focus on the color cube. That is what the meaning of this one. So that is why um, the color cube will be moving in the angle change in a clockwise direction. That is what the job of blood post redisplay. So the meaning of this one is your display will focus on the spin cube instead of the main function. So that is what the job of blood post redisplay. Actually, next should be to be displayed is main function. Instead of main function, just you post that one and you focus on the spin cube function. That is what the meaning. It is focusing on that. And as I told already, um, whenever any mouse event is not occurring, your cube will spin in its own direction. So here you can observe, suppose if left mouse button is clicked once, automatically what happens? It changes the value of axis as 0, and immediately the value of axis 0 will be taken, and the rotation takes place. The meaning of that particular button is whenever you click on the left button, it moves in the x-axis, whereas whenever you click on the middle button, it moves in the y-axis, and whenever you click on the right mouse button, it moves in the z-axis. So whenever you do any action, interactive action like this, axis value change. If the axis value is 0, it moves in x direction. If the axis value is 1, it moves in y direction. If the axis value is 2, it moves in z axis. So that is what the job of the thing. Okay, next we will move to the main function. Now here, simultaneously we are calling glut idle function, glut mouse function. The meaning of this one is spin cube will go on spinning in its own direction, in a clockwise direction, whenever any mouse event is raised by the user by clicking on the left, right, or middle button, automatically what happens? It stops spinning and it will move to the um, function called mouse function. It changes the axis value, then once again it starts moving in a particular direction. So this is about the um, color cube rotation. And then GL enable, this is the depth test, this is for the 3D display. And you know this black main loop, this is to display the objects in continuous fashion without stopping it. So finally, once after doing all these things, you will get the output in this way. So your uh, color cube will be moving in this way in clockwise fashion. Whenever you click on the left button, um, it moves in the x-axis. Whenever you click on the middle button, it moves in the y-axis, and whenever you click on the right button, it moves in the z-axis. This is the third program, that is create a color cube and spin in the direction. This is the third program, whereas the fourth program is very much similar to the third one, but extra thing is in the third program we have added only the mouse event, whereas in the fourth program the extra keyboard event also been added. So just we can, if you want to move in X direction, we need to click on the X. If you want to move in the Y direction, we need to click on the Y character, Y key. And if you want to move in the Z direction, we need to click on the key called Z. So in this fourth program will also work. So this explanation is for both the for third program as well as for the fourth program. So okay, I think everyone have followed it. If any doubt is there, post the doubts, and all of you seriously go through the video and try to understand the thing and prepare well. Thank you. Thank you.